Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is dividing radical expressions. So, one of the first things we want to do then is going to be to divide. So, step one is dividing, right? And then step two is actually just simplifying. So, really, they kind of gave you the steps in the directions. And this is a lot like the one I just did previous to this on multiplying radical expressions because, multiplying and dividing are pretty similar. Kind of like how you say like two sides to the same coin, that kind of thing. So here's what we do, right? And there's a couple ways you can mess this up. And the main way that people mess this up is by trying to divide a radical number with a regular number. Don't do that, right? So radical numbers have to go with radical numbers, regular numbers with regular numbers. So what I mean is I can simplify the 15 and the 20 here, but I can't simplify the 5 with the 15 or the 20 in any way. So what is 15 over 20? Well, that would be 15 is 3 times 5. 20 is 4 times 5. So they both would divide by 5. Right? So 15 divided by 5 is 3. That's the square root of 3 over 5. Still a 5 on the outside here. And then 20 divided by 5 is 4. Okay. So actually, once we've done that, then we look to see if we can simplify. And we can. We can actually simplify quite a bit here because the square root of 4 is 2. So 5 times the square root of 4 is 2. And then I have the square root of 3 over 5 times 2 is 10. And then I'm done. So I'm actually done because, well, I simplified. But also later on, there's going to be this thing where like there's a radical number in the denominator. And, I mean, if you're watching this and you're a math person, correct me if I'm wrong, but I don't think there's any good reason to simplify a radical in the denominator. It's just this thing they make you do. It's just this thing they make you do. And there's really no point. But everybody, every textbook that I've ever read on this says that you're supposed to rationalize the denominator. So let's figure out what that looks like later on. We don't really come across that for a while. So let's see. Both of these divide by 2. But maybe what about 4? Yeah, they both divide by 4, right? 8 divided by 4 is 2. 100 divided by 4 is 25. Oh, hey. We know what the square root of 25 is. The square root of 25 is 5. And then we're done. Not so bad so far. Okay, let's do it again. What do both of these divide by? Because, again, they are square roots, right? So we can simplify these. We can divide. We can divide a little bit here. Divide by 3. They both divide by 3. Okay. Square root of 6 divided by. And when I say divided by, and I'm not putting a square root on the number, there is actually technically supposed to be a square root on the number. I just think it makes it look more complicated if you do it that way, right? So I'm not technically dividing by 5. I'm actually technically dividing by the square root of 5 for number 1. And then for number 2, I divided by the square root of 4, actually. So I actually divided by 2. But I don't like to do that. It just makes it look more sloppy, I think. So that's why I avoid doing it that way. 6 divided by 3 is 2. 27 divided by 3 is 9. Square root of 9 is 3. And we're done. Okay. This time we've got a number on the top and a number on the bottom. Let's see. Both of these look like they divide by 4. 3 and 2 don't have anything in common, so we can just, we don't have to worry about that. 20 divided by 4 is 5. So I have 3 still, right? So 3. 20 divided by 4 is 5. And then 4 divided by 4 is 1, so it's just the square root of 1, which is 1. So it just goes away. It's just a 2 left over, and that's it. All right. Let's start switching colors here. Switch to a nice green. All right, number 5. This is the first time that you'll see what I was kind of hinting at earlier, and that is there's nothing really to divide because 4 and the square root of 5, first of all, they don't even have any factors in common, but that wouldn't even matter because they're not the same kind of number. They're not like terms. I can't divide them if they're not like terms. They're not the same kind of number. Square root of 5 is a radical. Radical. So I can't divide them. But I also can't really simplify either. So I would normally be done. Except that, for whatever reason, people don't like it when there's a square root in the denominator. We got to get rid of it. You can't get rid of the square root in the expression completely, but you can move it to the top. All right? And by move, I mean we can do some math and make sure there's not a square root in the denominator, but there will be one in the numerator. So let's see what happens. Well, in order to get rid of the square root, you have to do the opposite operation, right? Well, in an equation, you can do whatever you want as long as you do it to both sides. In a fraction, you can only times or divide stuff on the top and the bottom evenly so that it stays the same fraction. So in order to keep this the same, I have to multiply by the square root of 5 on the top and on the bottom. I can do that because with fractions, you can multiply or divide on the top and the bottom and keep it the same. When I multiply something by itself, that's the same thing as squaring it, and that'll make the square root in the denominator go away. Square root of 5 times square root of 5 is the square root of 25, right? 5 times 5. And then here, nothing combines. Well, what's the square root of 25? It's 5. And there we go, right? And that's what we have to do. So that is the thing. Over here, we can simplify this a little bit. The square root of 4 is 2. So I'm going to start by simplifying that a little bit. 5 root 3. Can't really divide. 2 and 5, they don't divide. So I just times by the square root of 3. So then I have 2 root 3. 3 times 3 is 9. Square root of 9 is 3. So then I have 15. All right. And from this point forward, I'm going to start skipping some of the middle steps because that took pretty long to do number 6 step by step. But I'm going to start skipping some of those middle steps. And if I start to go a little faster, and I start to kind of gloss over some stuff, it's because I just did a video on multiplying radical expressions last week. So I'll put a link for that in the description below, and you can check that out for like a refresher on some stuff, just in case. Okay. I can times 5 and 3, and I get 15. 3 times 3 is 9. Now, for 5 and 6, what I did was I multiplied the denominator by itself. But when you multiply a square root by itself, it basically just cancels out the square root because it's the square root of 3 squared, which is 3. So I'm going to start skipping out that middle step from here on out. All right, and that's it for that one. 3, 3. I can multiply the tops. And then on the bottom, I would have 2 times 3, which is 6. Now, that does not combine, right? It's not 1. It's not the square root of 1. It doesn't combine. Because remember, square root numbers and regular numbers, they don't go together. Okay. Starting to get a little bit more ramped up here. Let's switch to a nice yellow and increase the thickness a little bit because yellow is kind of hard to see. Okay. Now, lots of stuff to divide, and we're including letters here. Lots of letters. X squared divided by x to the first power is just x. y cubed over y cubed would cancel. 3 over 5 is still going to be 3 over 5. And then I still have the 4 down here, right? And actually, I might decrease the thickness a little bit. That's a little bit too much. Put that down a little bit. So at this point, we're pretty much done. We just have to rationalize the denominator. So when I times it by the square root of 5 on both sides. And then remember, square root of 5 times square root of 5 is 5. Okay. And then on the top, I can multiply all that stuff. That's going to be 3 times 5 is 15. And 4 times 5 is 20. Right? And that's as far as we can go. Right? We can multiply the 3 and the 5 on the top. They're both square roots. The x is still going to be under the radical. On the bottom, 4 times 5 is 20, and that's it. That's the answer. Okay. So you just got to be careful and do it step by step and get lots of practice in, and you'll be good to go with this stuff, right? That's how it always works. Practice makes perfect, they say. So we want to divide, and so we're actually dividing by square root wise. We're dividing by 5, because 15 and 10 both go into 5. We're also dividing by x. That makes the x's go away. And we're dividing by a y. That makes one y, one power of y go away on each side. Okay. Well, 15 over 5, 15 divided by 5 is 3. X divided by x is nothing. Y divided by y is nothing, right? 1 technically, but you don't need to put times by 1. All right, I still got a 3 on the bottom. 10 divided by 5 is 2. X divided by x is nothing. Y cubed divided by y. Well, when you divide y's, it's just like one power goes away from each side evenly, so you're just subtracting. You're subtracting the powers of y. Y cubed divided by y, aka y to the first power, is y squared. Right? And then what happens here is, well, we can simplify. Because y squared is just y. So this would be the square root of 3 over 3 square root of 2y. And then that y is not connected to the square root. So I could put it next to the 3, but maybe I'll do that on the next step. So then what we want to do is we want to times both sides by the square root of 2. Because that's the only thing left over in the denominator, is the square root of 2. We have to rationalize the denominator because they said so. So then, if I take square root of 3 times square root of 2, I can times those because they're both square roots. So square root of 6 over square root of 2 times square root of 2, square root of 2 squared, which is 2, right? Or, remember, earlier, you could do square root of 2 times square root of 2 is square root of 4, which is 2. Right? Either way. So we have 2. So it's 3 times 2 times y, which is 6y. So I have the square root of 6 over 6y. Whew, that was a doozy. All right, next one. So we have a few things here. We want to see if we can simplify. Let me break out the eraser here. Okay, so that square root is over the a as well. Okay. Now, we're not going to be able to cancel out those a's, though, because on the top there's two things. It's 3 minus 3 square root of 3a. That complicates things. What that means is we can't just cancel out the a's unless we split up the fraction. I could write it as 3 over 4 root 8a minus, so all of that, minus 3 root 3a over 4 root 8a. I could split the fraction up and then do it that way. But let's just go ahead and rationalize the denominator, and then we'll kind of just deal with the leftover from there. Right? 8a. 8a. Okay. So it would actually be distributing that 8a into two things. I'd be distributing it into that and that. So I have 3 root 8a. And actually, you know what? Before we, yeah, we should. So you don't have to do this, but I'm actually going to go back because I'm going to probably run out of space if I do it this way. Before we clean this up and before we rationalize and do all the things, we can actually simplify the 8. The square root of 8. 8 is 4 times 2. So it's the square root of 4 times the square root of 2, which is 2 root 2. So since that simplifies, I can actually, and let me go ahead and box this answer again. I can actually go ahead and write that simplified. And I can factor out a 3. 3. I don't know if I'm going to, though. A lot of things you could do here, but this one's kind of tricky. If the square root of 8 simplifies to 2 root 2, then that means a 2 would be coming out, and it would be 4 times 2 root, and then there's still that a in there as well, right? So 2a, which is 8 times the 2a, right? So actually, let me, can I move this text? I wonder if I can move it. No, okay. So we want to then multiply by the square root of 2a on the top and on the bottom. Okay. And then we would distribute that 2a. This really ramped up here, guys. This is crazy. So we would do 3. So that's going to equal 3 root 2a minus 3. And then I can multiply the roots here. 2 times 3 is 6. A times a is a squared. 6a squared. All over. That's going to be 8 right there. And then the square root of 2a times the square root of 2a is, well, 2a. All right. And I think what I'm going to do is I'm going to bleed over a little bit onto the top of the next one, because there's still more work to be done here. Square root of a squared is a, so it'd be 3 root 2a minus 3a root 6 all over, and that's going to be 16a. And I believe that's as far as you can go. All right, so that's actually the final answer. I'm not going to box that in yet, because if I do, it's going to spill over onto number 13, and I'm not going to be able to tell what something is on number 13. So I'll wait to box that until I'm done with 13. But that is it for that one. Whew, crazy. Okay, so we have another one, number 12, where we're doing this. And let's try it a different way. So your teacher might want you to split up the fraction. I mentioned you could split up the fraction. Let's try that on 12 and see if you like that more. If your teacher doesn't care, as long as it's, you know, a simplified answer, then let's see it. Well, if we split it up first, we would do 3n squared over the square root of 10n. Okay, plus, and then we can simplify that. So 2 over 10. Well, let's go ahead and write it out. Well, I don't know if we'll have space, so let's go ahead and simplify it. 2 over 10 is 5, so I'd have a 5. N squared over n is n, so I'd have an n. Square root of n, square root of 5. Okay. Now I have to rationalize two different denominators. Well, if I rationalize the first denominator, I would get, and let's do it down here. I would get 3n squared root 10n over 10n. Multiply the top by the square root of 10n, and the bottom by the square root of 10. On the top, or on the second fraction, I would multiply by the square root of 5, square root of 5n over 5. And then I can do just a little bit more, because I now have an n outside of the radical that I can simplify a little bit. 3n root 10n over 10 plus root 5n over 5. Right, those are 5s, not 3s. Okay, so you could do it that way as well. You could do it either way. And if you needed to, you could put the fractions back together if your teacher wants the fraction back together by timesing the second fraction by 2 on the top and the bottom, and then you could put them back together that way. Right? So it works out that way as well. All right. I think it's time to switch colors. Yeah, we've done 4 problems in yellow. Time to switch to orange. And let's go back to a smaller thickness here. All right, same thing. So we are going to multiply. Actually, this simplifies. Square root of x squared is x. So that simplifies first. Let's simplify that. This would be equal to 4x cubed minus 3 root 3x over 3x root 3. So then I'm going to rationalize the denominator by multiplying the top and the bottom by the square root of 3. And the other way to think about multiplying the top and the bottom of a fraction by anything is to just multiply all the things. There's 3 things. There's 2 things on the top, and there's 1 thing on the bottom. All the things, which we call monomials or terms or expressions, all of those things are separated by plus and minus. So if you see pluses and minuses, that's going to separate things. I just call them things because that's easier. So the first thing is 4x cubed. The second thing is 3 root 3x. And the third thing is 3x root 3. It's on the denominator. If I multiply everything by the square root of 3, I get 4x cubed root 3 minus. Now if I multiply this by the square root of 3, then I get the square root of 9, which is 3. Okay, so it's 3 times 3, right? So this 3 and that 3, and then I multiply by the square root of 3, which is now the square root of 9, which is 3, and then I have a root x. Okay, over, and if I multiply this by the square root of 3, I get 3x and 3, because the square root of 3 gets multiplied by itself. Okay, so again, I'm skipping out some of the middle steps, but it's partly because of space, and I don't have the space to do it, and also partly because as you go along, you want to start to learn how to solve the problem a little faster, a little better. Not by rushing, just by skipping out some of the middle steps that are not as important to write out, but still to do in your head. So anyways, once we clean this up a little bit, I think we'll be done here. So 4x cubed root 3 minus 9 root x over 9x. And I think that's as far as we can go there. All right, so that's it. Boom. All right. So again, we have something that simplifies here. We have, oh, and on the top as well, that's k squared. The trick to taking square roots of large powers is just to divide by 2. Right? If you're going to take a square root, divide the power by 2. So k2 root 5 plus 3 root 2k over, and 1k power comes out. 3 divided by 2 is 1, remainder 1. So 1 power of k comes out, 1 stays in. So that means I'm going to multiply both the top and the bottom by the square root of 3k. So it's going to be k squared. And then I'm multiplying by the square root of 3k, so that's 15k. Then 3 root. And I'm going to multiply the top and the bottom by 3k, so that's going to be 6k squared. Over k. Root 3k, root 3k is 3k. All right, so I'm definitely going to get some stuff that simplifies here. That's a k. That's a k. That's a k. We've got at least 1 k in everything, so I'm actually going to divide out a k. So this is k, right? K squared. Square root of k squared is k. So I'm going to take out 1 factor of k from everything, and that should be the final answer. Okay, got that. Then that's 3 root 6. Because the square root of k squared is k, I'm taking out 1 factor of k. On the bottom, I get 3k. right? And that should be everything. The first term right here has a k, but not a 3. This one has a 3, but not a k. So it looks like something else might simplify, but it doesn't. That's it. That's as far as we can go. Unless you were to split up the fraction, right? Which I only split up that fraction once because you guys might be able to split up the fraction, right? So for number 12, I split up that fraction just to show you what that would look like. But normally, teachers want you to keep the fraction all together. Normally, that's normally the rule. So we go ahead and box in that this one right here that I said I was going to box in. All right, just for consistency. All right, so go back to orange here. And okay, so this time, ooh, they ramped it up again. They ramped it up again because if I just multiply by the square root of 5, it's not going to be good enough because I have to multiply it by everything. So it'd be 3 root 5, okay, over, I have to multiply the square root of 5 by both things in the denominator now. It'd be 4 root 5 plus 4 times 5, which is 20. And I wouldn't get rid of the square root in the denominator. So we're stuck. We can't go on. It's impossible. There's no answer. Nothing in sight. Except there is. There is something we can do. And that is the magic of conjugates. If I multiply a binomial, right, 2 terms, 1, 2, binomial, by its conjugate, and here's its conjugate, it's going to be, I'm going to multiply on the top and the bottom, by 4 minus 4 root 5. 4 minus 4 root 5. Wrap it up in parentheses here. That's a conjugate. So a conjugate is the exact same 2 terms, 4 and 4 root 5, but with a different sign in the middle between them. Right? And you would only change one sign because notice the 4 is still positive. So later on, if the first sign is negative, you don't flip that sign also. That would make it the opposite, not the conjugate. Right? Opposite and conjugate are not the same thing. Conjugate is kind of like a hybrid between the opposite and the same. Right? It's like hot water, cold water, and then lukewarm water. It's like lukewarm water. Okay? So it's not the opposite, but it's not the same thing either. Something did change, but I didn't make it the opposite. The opposite of 4 plus 4 root 5 would be negative 4 minus 4 root 5. Okay? So you just change the sign in the middle only. That's important for number 16 and 17 especially. Okay? So we're going to go ahead and do that because there's not really anything to simplify. So when we multiply those out, here's what happens, right? You do FOIL, right? First, outer, inner, last. So on the top, we just distribute. That's going to be 3 times 4. It's 12. Right? And actually, there's going to be an extra factor of 4, but it's fine. We'll figure it out. So 12 minus 12 root 5. Okay? And then on the bottom. Okay, so when I FOIL this out, first times the first. Outer times the outer. 4 times minus 4 root 5 is minus 16 root 5. Inner times the inner, plus 16 root 5. Last times the last, minus 16 root 25, or 5. Okay? And that's actually going to get rid of the square roots. You're like, oh, hey, but they're still square roots. Oh, but they cancel because they're the exact same square root. And that always happens. So what you can do actually is you can skip the middle steps, the O and the I, because they will cancel if you're multiplying conjugates. Don't skip the middle steps if you're not multiplying conjugates. It only works when you're multiplying conjugates. If you are multiplying conjugates, you can just do the F and the L steps because the O and the I will always cancel. Okay? So I have 12 minus 12 root 5 on the top. On the bottom, I have 16 minus whatever 16 times 5 is. What is that? Well, a little trick to multiplying things by 5 in your head really quickly is to take half of the number, right? So half of 16. What is that? 8, right? And then add a 0, 80. 16 times 5 is 80. So 16 minus 80, okay? Well, what's 80 minus 16? 80 minus 10 is 70. 70 minus 6 is 64, and it's negative 64. Whew. Okay, that was a little bit there. But everything divides by 4 still, because I multiplied by 4 minus 4 root 5. I could have done it a little bit faster, but since this was the first time, on this worksheet at least, that we've done conjugates, I figured I would spare you that extra pre-step in order to make it easier later. So we can divide everything by 4. Let's divide everything by 4. It'd be 3, right? 12 divided by 4 is 3. Minus 3 root 5. 64 divided by 4 is 16. And now we're done. Whew. Okay. Now we do it again. So we're going to multiply by the conjugate. Right? So I'm going to times by negative 5 plus 3 root 3. Negative 5 plus 3 root 3. On the top and on the bottom. All right? So on the top, I just factor over, distribute over negative 25 plus 15 root 3 over. Now, remember, I can skip the middle steps. So first times the first, 25. Last times the last, that's going to be minus 3 root 3 times 3 root 3. Okay, what is that? Well, 3 times 3 is 9. Root 3 times root 3 is 3. 3 times 9 is 27. Whew. All right, so that's going to simplify to 25, negative 25, plus 15 root 3 over 25 minus 27 is negative 2. Right? And that's as far as we have to go. Now, I have been leaving negatives in the denominator. Most teachers are fine with that. If yours is not, you would just need to multiply everything by a negative number. So switch the sign on everything. Right? So for 15 and 16, there's 3 things. Change the sign of each of the 3 things. And then you're good to go there. Okay? Speaking of good to go, we're good to go with the color orange. Time to move on to red. We're almost done here. We're going 2, 3, 4, 5, 6, 6 more, and that's it. Wow, short worksheet. Okay, so short compared to some. It's kind of mid-range, actually, if you think about it. Because I've done some that are, like, way shorter. But anyways, all right, so, oh, here's the thing. So I mentioned this in 15. It's 4 plus 4 root 5. You can actually factor something out first. So let's do that, because that was the thing that I mentioned. If we factor out a 3, it makes our lives easier for later. So if we factor out a 3, factor out a negative 3, actually, it'd be 1 plus root 3. Now, here's the thing. I don't have to multiply by negative 3 on the top and the bottom. The thing I need to multiply by is the binomial with the root in it. So I can actually ignore the negative 3 now and just multiply the top and the bottom by 1 minus square root of 3. Right? And that's a little faster because with number 15, at the end there, I had to divide everything by 4 because I had an extra factor of 4 that wasn't there initially. I'm going to avoid that scenario by factoring out the 3 at the front end. Now I'm not multiplying out an extra factor of 3 that I don't need to multiply by. Okay? You don't have to do this pre-step, but it makes your life easier for later, right? Do a little bit of pre-work, and then it makes it better in the long run, okay? It's like if you've ever heard of like an ounce of prevention is better than a pound of cure, right? Do a little bit of work at the front end. It makes the rest of the problem easier and shorter, right? So try to look for that extra factor if there is one, okay? So on the top, distributing 5, okay? Minus 5 root 3 over negative 3, okay? And then I'm going to have a parentheses. I'm going to FOIL that out. 1 times 1. Root 3 is 3. 1 minus 3 is negative 2. Negative 2 times negative 3 is positive 6. Right? So 1 minus 3, negative 2 times negative 3, positive 6. And that's as far as we can go, actually. That wasn't too bad, right? A lot easier. That would have taken just as long as number 15 if I didn't do that pre-step, right? Notice how that was way shorter. Okay, now, this is going to be a little harder, but it's still a conjugate. I'm still multiplying by the conjugate, okay? Root 2 plus 5 root 3. Root 2 plus 5 root 3. All right, so I just distribute on the top. 4 root 2 plus 20 root 3. Now on the bottom, remember you can skip the middle steps. So first times the first, that's 2. Last times the last, that's minus. 5 times 5 is 25 times 3 is 75. Right? 25 times 3. 3/4. So then I get 2 minus 75. 4 root 2 plus 20 root 3. 2 minus 75 is negative 73. And that's it, because I'm pretty sure 73 is prime. Let me know if it's not in the comments. But I'm pretty sure it is, which means we can't simplify anything, and we're good to go. Okay, so notice that one seemed like it was going to be different because it was a square root of 2 minus 5 root 3 on the bottom, but it wasn't. I just still multiplied by the conjugate. Don't let that throw you off, okay? I can factor out a 4 here, so I'm going to do that first. 2 plus 5 root 3. And you could factor out a negative. I'm not going to. Just factor out a 4. So I'd have negative 1 plus root 2. So I'm going to multiply by negative 1 minus root 2. Okay. So then I'm going to have to FOIL on the top and on the bottom. Now on the top, that's not a conjugate. So I do need to do each of the 4 steps. Firsts, outers, inners, lasts. It's hard to do that extra S on the end sometimes. I do want to go ahead and do a full FOIL. So 2 times negative 1, negative 2. Outer times the outer. Inner times the inner. Last times the last. Right? And none of that goes together because they're all different roots. On the bottom, I have 4. And then these are the conjugates, right? So I do want to go ahead and skip those middle steps for time. 1 minus 2. That wasn't that bad, actually. Okay, so 1 minus 2, that's negative 1 times a negative 4 is, times a positive 4 is a negative 4. So everything is negative, actually, and you don't have to do this, but since everything is negative, let's go ahead and switch the sign on everything, right? Because basically that's negative 1. So let's make everything positive. 2 plus 2 root 2 plus 5 root 3 plus 5 root 6 over 4. And there's nothing to simplify because not everything on the top goes into 2 or 4. So we're done. All right, same thing here. Except this time we don't have anything to factor out first. So I would multiply it by the conjugate. 4 plus root 5. 4 plus root 5. All right. So on the top, I'm going to need to do a full FOIL. First times the first. Outer times the outer. Inner times the inner. 8 root 2. Last times the last. 2 root 10. Kind of ran out of space there. Okay, over. First times the first. Last times the last. 16 minus 5 is 11, which is definitely prime. And so that's actually it. It would be 4 root 5 plus 5 plus 8 root 2 plus 2 root 10. All different roots again. Root 5, no root, root 2, root 10. All different roots. Over 11. And that's it for that one. Okay, last color. Moving on to purple. Went through the whole color spectrum there. All right, so again, with the 5s, right, there's nothing to simplify or factor out though. So, boom, boom, boom. Watch is going off. There we go. So, we want to FOIL, and we want to FOIL on the top and on the bottom, technically speaking, right? Even though on the bottom it's a conjugate. So, we do first times the first, outer times the outer, inner times the inner, last times the last. Okay? And then firsts, outers, inners, lasts. Okay? And then actually more stuff is going to simplify this time because we have a root 5 on the top and on the bottom. More stuff goes together. So I have two sets of like terms on the top here. That's 7 root 5. And then these guys to go together here as well. 5 plus 12 is 17. 16 minus 5 is 11. And that's as far as we can go again. But that time, more stuff simplified. Interesting. Okay, so actually before we get to this last one here, or maybe as I'm doing it, if I can manage to multitask, then if you found this helpful, all this stuff is also on my website. Not well, actually, yeah, all the videos as well on my blog, but all of the worksheets and stuff. Like I take these worksheets with the work in them and I save them, and I have them on the website, so you can go check that out. And I have an awesome free resource at the front of the website. You go to myersmathematics.com. It's called the 5 Math Mistakes Everyone Makes and How to Avoid Them. So go check that out. That's an awesome free resource as well. And message me. I have my email in the comments on pretty much every video. So shoot me an email if you need anything as well. That's what this is for. This is for you. This is to help you. So let me know how I can help you better, how I can help you more. I do private tutoring also. So shoot me an email if you're interested in that. And yeah, let's jump into this last one here. So what I did was the conjugate, right? All I did was change the sign. So first times the first. I'm starting on the top. First times the first. Outer times the outer. Inner times the inner. 16 root 15. Last times the last. Okay. Quite a bit of stuff there. All right, and then on the bottom, first times the first, 16 times 5 is 80. Last times the last, that's minus. 3 times 3 is 9, times 2 is 18. Right? 80 minus 18, again, that is going to be 62. So 12 root 5 minus 9 root 2 minus 16 root 15 plus 12 root 6. All different roots again over 62, which is 31 times 2. But not everything divides by 2 on the top. We have a 9 root 2. So that doesn't divide by 2. So actually, we're done. That looks really ugly, but that's it. That's as far as we can go. That's as far as we can go. Almost everything divides by 2. The minus 9 root 2 does not. So that's actually it, right? And if you don't believe me, you can always check the answers in red. It's red, so that's how you know they're serious. And looky there, right? Crazy. So, and actually, these answers like this are always on here, on every like Kuta worksheet that you have. Pretty much, unless your teacher has like a paid subscription to Kuta software, and then they can create their own worksheets that are different from the ones that are readily available online. So if your teacher is a crazy person and they pay for their own subscription to Kuta software, then they might have a worksheet where you don't have the answers included in it, but all the ones that teachers pull from online, which is like 95% of teachers, they pull from these Kuta worksheets online. They have the answers in them. So if you need to check to make sure you're getting the right answer, you don't have to look at one of my videos. You can just do it yourself. You can just Google the title of the worksheet, and it'll come right up. And then scroll down until you start seeing red, because those are the answers. Right? That's it. Again, hope this was helpful. Go check out my free stuff on my website. Like, subscribe, comment, all of that kind of good stuff. And I'll see you guys in another episode real soon.